So we'll start with the your problem which you have selected and how we'll be using the epidemiology and statistics in your the problem which you have identified. So we start with the problem statement or the topic of the research which you have selected. I can see the Vinayak. Vinayak, can you tell me the topic of your study?
Sir, actually, I haven't selected a topic yet.
Okay, tell me what are you doing?
Sir, I haven't selected the topic yet.
Hey, but what are you are doing right now? So basically, you are a student, you are a doctor,
I'm a student, sir, a third year medical student.
or you're a medical student. Now, let's say you have some problem, right? For example, the depression among the students. Okay,
Yes, sir.
so we want to find out that how many students in a university. There are two like students in university, and we
Yes.
want to find out, let's say, depression score. What is the depression score or the IQ score? IQ, let's say IQ is much better. And if you want to find out the mean IQ of the university students, we can apply the statistics somewhere. And take another small example that in your uh, class, let's say there are 70 students, and out of 70 students, you have the list of IQ of all 70 students, and you want to find out how many students are outlier. That means you want to find out the mean, you want to find out standard deviation, and want to find out that how many are actually belonging to the group and not belonging to the group. So let us start, take this example that IQ of 70 individuals, mean IQ of 70 students of your class is right down 110. Mean IQ is 110. And standard deviation is 10. 10 is the of IQ and standard deviation is 10. Now, the question is how many how many are below 90? How many are below 90? Can you find out that? Very simple question. So, 110 is the mean and 10 is a standard deviation. I will write in chat so that you can give answer also. So, mean IQ of 70 students is 110 and standard deviation is 10. My question is, we want to support those who are below 90. So the question is, how many students will less than 90? So the answer should be between 90 to 130. How many people will be there? 95%. Okay? Because mean plus minus 2 standard deviation covers 95% of the students. But then less than 90 and more than 130 by and large should be 2.5%, 2.5%. So 2.5% will be less than
90.
90.
Yes.
So 2.5% of 70 that you can calculate, it would be, let's say 2.5, 100 must say 2.5, 70 must say how much? It will be around 2 students. So you need to support 2 students who are having a relatively less IQ compared to your the class. Now suppose one person is having an IQ 150. Can it be of your group? Yes or no?
150.
One person is having IQ 150 among your 70. What do you say? He is within your group or he is outside your group?
Outside.
So our answer would be, we cannot say inside the group or outside group. We can say that probability that he is belonging to the group is less than 2.5%.
Oh.
95% is the confidence limit that he is not within the group. This is how we are using the Z. So Z is equal to mean X bar. I don't know how do I write, but then let's say mean. Let me write the mean, right? Divided by standard deviation. So in this case, if I give you example, that find out if a student is having IQ 100, IQ is 100, then find out Z. Find out Z. Let's all of you do it and share in the chat. Then we'll go for, this is one kind of Z. There are total 5 types of Z. Gradually we'll be going for that. If a question is, if X is equal to 100, then what is Z? Is
90.
Z is a distance of the observation from the mean. So what is the distance between the mean is 110.
10.
So what is the distance between 100 and 110 in terms of Z? So here the Z is equal to
100 minus 110.
So Z is -1.
Minus
divided
10.
by SD is a 10, right? So is equal
1.
to 1.
1.
It is 1 SD away. It is a 1 SD away. So -1 or 1, that's okay because it's left side or right side. So no problem. So it's one standard deviation away. That means up to 2 standards, we don't mind. That is what we say. So this is one kind of Z. And if Z is more than 2, what does it mean? That P, probability of being in the group, is less than 0.05. This you should understand, because if Z is more than 2, that means suppose this is 150 or 160, then it is more than 2Z away. More than 2Z away, that means the probability that is belongs to the group is less than 5%, because within the group 95% people lie between mean plus minus 2 standard deviation, but it is more than that. So we say that the chances that it belongs to the group is less than 5%. That means probability is out of 1. So P is less than 0.05. So this is how we use the probability. We use the Z. Now the next question is, this is about whether the person is belonging to the group or not. Now we want to find out, based on a sample, how far the mean of the population is. So the question is, in a village, let's say village Puchedia is having the 10,000 population. And we want to find out the mean calorie intake of the population. Intake of population. If this is a question, then suppose we are taking a sample. Sample we are taking of, let's say 400. We have taken sample size 400. And this 400, we calculate their calorie intake by the food survey. And we found that the mean was 1800 calorie. 1800 calorie. The standard deviation was 100. So my question is, what will be the mean caloric intake of the population of Uchedia? Can anyone answer?
So this is we are calculating standard error of mean, right?
Yes.
Of the population.
Now we need to find out standard mean. For that,
Correct.
the question is, based on sample, we are talking about the population.
Population.
The sampling
Yes.
error.
Correct.
And to find out this sampling error, we need
Variance.
to have some kind of idea. So here, some of you may find difficult, but my the question is, out of 10,000 population, if I want to take a sample of 400, how many such sample I can take?
400.
How many such sample I can take?
22 samples.
Wrong. Anyone else? Dr. Alvin, Dishant, Rashmi, anyone? So let me ask a simple question. If out of 10,000, I want to take a sample of hundreds, how many such sample I can take?
100 samples.
100.
So that is the wrong thing, because
Hmm.
when I want to take a random samples, you take 100. But then if I replace one back and one another one, my sample changes.
So infinite.
So not infinite, but like thousands of sample I can take. And
Okay.
suppose these thousands of samples, from each sample I am taking a mean.
Hmm.
From each sample I am taking, and on x-axis I write down the mean value. On y-axis I write down the number of samples showing a particular mean.
Hmm.
This is I am explaining so that you can understand what is a standard error. Now, when I draw this x-axis the means and y-axis the number of means, then there will be a mean of the means.
Huh.
There will be mean of the means.
Hmm.
And other means will be standard deviation around that.
Correct.
And that standard deviation is known as a standard error.
Correct.
You know, standard error is also one kind of standard deviation.
Deviation. Correct.
But then we call it as a standard deviation of means of samples around the mean of the means. So that what we call as a standard deviation, but now we can call it a standard error. But then for that we need to go thousands of samples. Instead of what the statistician did, that standard error will be more if there is sample size is less. If sample size is less, sampling error will be more. If sample size is large, then sampling error will be less. So, and if there is more deviations within the sample, within the sample observations, then it is difficult to talk about the population, so standard error will be more. So it is also known as standard deviation is square. What you say, root. You can also write this root as d square. Meaning is square upon
N.
size. So s d square upon n, that will be the standard error. So more the standard deviation, more the standard. And it inversely proposes the n. So now in this case, if you want to tell me what will be the caloric intake of the population, just try to calculate. So here, mean is already given to you, right? Now, the standard deviation is also given, n is also 400. So you try to calculate that root st square upon n. So root of st square 100. So
10.
10,000 divided by the
4.
400, and then we take a root of it. So 100 by 4 is a 25. And
Yeah.
root of
Root of.
is a 5. Right?
Hmm.
The square is 10,000 divided by n is 400.
Yes.
Then 4 so 25. So 25 will be the uska bhi root lena hai, right?
Hmm.
So it will be the 5.
5.
And then you- So the mean is 1800 plus minus 2 standard error, that is plus 10 and minus 10. That is how you calculate. Just let us confirm the rate 10,000 as the square. So when you say the population mean, you can't say that exactly it will be 1800, but population mean plus minus, you have to say 2 standard error.
Hmm.
Because 95% of the time, your population mean will be plus minus 2 standard deviation we use. Here we use the word 2 standard error. Because this is, we are based on sample. When we talk about the population, the word we use is standard error. And now our standard is a 5. So 1800 plus minus 5, 2. That is 10. So our answer is 790 to 1810 will be the mean caloric intake of 10,000 patients. That is the answer. So based on the small sample, we are able to talk about the population mean.
Mean.
Here also you can use the Z. How you can use the Z? Suppose the question is the actual data source of the community, the population actual when we found out, that was 2000 calorie. And the question is whether your sample was appropriate or not. This is a Z is equal to sample mean minus population mean divided by standard error. This you need to understand that how far the distance is there between sample mean and population mean divided by standard error. If it is more than 2, it is significantly different. And you can say that sample was not representative. So
Okay.
in this case, 1800 minus 2000 divided by the standard error is a 5. Then the answer is 200 by 40. Is a 40 standard error away. You can say the sample was taken from a biased population, maybe undernourished population, something like that. So it was not the representative sample. So standard error of mean is used to find out the population mean based on a sample mean, or to find out whether the sample is representative of
Of the
population.
population mean.
This is how we do it.
Yes.
Now the next question is, we'll take another question. Rashmi, when can you tell me what could be your problem? What could be problem statement? From that, we take another example for standard error of difference between two mean. And then we'll go for AP info, how it can be done. Any problem statement that will be easier to understand.
Sir, currently I'm thinking of a study, uh, like tuberculosis, a case control study,
Yes.
about different outcomes,
Hmm.
either favorable or unfavorable,
Hmm. So
and
here,
to take mean of it. To
here we want to find out difference between two means. So what we'll say that with regimen A, for example, the recovery is within, let's say, 3 months, 180, is within 80 days with standard deviation of 20 is the S, the standard deviation, right? And with the regimen B, the mean days of recovery is 120 days with standard deviation of 10. If this is a question asked to you and you want to find out whether this difference is statistically significant or not. So in this case, you need to find out the standard error of difference between two mean. So difference which two mean? This 180 days and 120 days. With this is 60 days are significantly different or not. In this case, we need to find out Z equals to x1, that is the mean 1 divided minus mean 2 divided by, so how much is the difference? And then the standard error of difference between two mean. Now the formula for standard error of difference to mean will differ a bit. There what we were using, standard is equal to root SD square upon n.
yes, sir.
While here what we will be using, root SD1 square upon n1 plus SD2 square upon n2. The same thing, just we add, right? So that you can calculate and tell me what is the SE over here. I will also calculate and you also calculate, right? SD1 square upon n1 plus SD2 square upon n2. So SD1 is 20. 20 square is a 400 divided by n1. Now in this case, we need to write down the n. Both the sample size can be equal, can be different also. For time being, let us keep it equal as a, let's say, 40. Right? Both n1 and n2 are 40. So root of the 12.5 would be approximately 3.5. So S is equal to 3.5, somewhere around this. So you can see that the 180 and 120, the difference is 60. 60 divided by 3.5 is roughly, it would be around 20 or 15. So Z is more than 2. So we can say that there is a statistically significant difference between A and B. So this is another type of Z. So we learned three type of Z. Z, when only there is a one group, from that we need to find out the deviation from the mean, how far the Z is away, how many standard deviation away. That is one. Then when you want to talk about population based on a sample, so as at that time, also you can find out the Z between the population and sample difference. So divide by S. Then here,
SD.
between two population you want to compare. So difference between two population mean divided by standard error. There also you can find out Z. Now we talk
The
about,
Z. Yeah.
so 3 Z we have learned, and everywhere Z more than 2. P is less than 0.05 and you can say it's significant. Now we talk about the proportion. Now in this case, tuberculosis itself, you want to find out that in regimen A, total 3,000 patients were there. And in that, when evaluation of a sample population, a 300 sample was taken, and we could find out that the 180, 280, 270 people recovered in sample, a small sample. The question is, 30 didn't recover. So out of 3,000, how many not recovered? What is your answer?
2,730.
So out of 300, 30 didn't recover.
Yeah,
So
30.
out of 3,000, how many not recovered? 300. Simple. If you go that way, 10%. But it is not like that. When you want to talk about a population based on a sample, there will be error. And that error, in this case, you will be able to find out by standard error proportion is equal to root P into Q upon N. This is how you find out. Now, P is percentage of recovered and Q is percentage not recovered. So, here you need to find out in terms of percentage. So, here SC is equal to P is 90% recovered multiplied by 10% not recovered. And then divide by N. Our N over here, sample is 300. So that answer is 900 divided by 300, right? And you need to take a root of that. So 900 divided by 300 will be a 3. And root of 3 will be somewhere around, you can say 1.5 or 1.7 like that. So SC is equal to root of 3. And root 3 you can take simply 1.7 or like that. So here you can say that the proportion would be 1.7 if you take double it. Why you say? The population proportion belongs to sample proportion plus minus 2 standard error. Sample proportion plus minus 2 standard error. So, multiply by 2 will be around 3.4 like that. This is a rough calculation. So, what you can say that in the population out of 3,000, percentage wise, 10% not recovered. In that case, 10% plus minus 3.4 plus minus 3.4% may not have recovered. That you can find out. So that would be around, let's say 7% to 13% of 3,000. This is how you can calculate based on a sample what will the population. Now, somebody says that in 3,000 patients, the recovery rate was 80%. Now, this is the other way we are putting. And your sample says that recovery rate is 90%. The same way. Then, what is the difference we do? 80 minus 90. The 10% difference. But in case your standard error is 1.7, that means Z is more than 2. So your sampling technique is wrong.
Wrong. Yeah.
You have not selected the right side of represented sample.
Okay.
This is how we can use Z. This is the fourth Z which we are using. And I expect even you are, let's say, 3 of maybe a 5% are there, but you should be able to apply this all kinds of 5Z in your study, we'll be using the epi info, how we can do this. So this is the fourth kind of Z. Now, there is a comparison between these two regimens, for example. And in this case, in group A, let's say 300 patients were taken and the recovery rate was 90%. And a group B, regimen B, you can say, the sample size was 200 and the recovery rate was 80%. In this case, my question is find out whether the regimen A and B are significantly different or not. So what we were doing in SE over here, if you look the SE over here, if there is a SE is equal to root P1 Q1 upon N1 plus root P2 Q2. Now, if you take this way, this is how you will be able to find out standard error of difference between two proportion. Root P1 Q1 upon N1 plus root. Then again, you need not write down the root because that is a whole root upon N2. Now you can calculate. Now all this thing will be done without any manual calculation by the software. But for understanding purpose, this 5 types of Z, right? So this is, you can find out in this case, what is SE. So P1 Q1 in this case is 90 into 10 divided by 300 plus this P2 Q2 is 80% into 20%, right? Divided by 200 and take a root of whole. So it will give you 3% 11. So 11 root of 11 would be around between 3 to 4, let's say 3.2 or like that. So SE standard of difference to proportion is equal to 3 point, let's say take 2. Now here, the difference is 80% and 90%. So Z is equal to, in this case, Z is equal to P1 minus P2 divided by SE. Here the SE is 3.2. P1 is 90%, P2 is 80% divided by SE, that is 3. So 10 divided by 3 would be roughly 3 or so. So in any case, Z is more than 2. And so we can say that this difference, 80%, 90%, is significant. It is significant because P is less than 5.05 because Z is more than 2. Probability that this difference can occur by chance is less than 5% or less than 0.05. So it is significant. This we are learning now 5 types of Z.
Yes.
So how we can do it with help of AP info, that will be our question. And that then you can say that you are now mastering all this, at least basic of the statistics. So let's go for that AP info. But before that, I hope that all of you have some question in mind. अंजलि जी, आपको कुछ पूछना है?
हाँ वही सर, देन अगर वो इतना सैंपल लेके पॉपुलेशन, तो पॉपुलेशन ही क्यों नहीं लेते डायरेक्टली? देन व्हाई यू वांट टू टेक सैंपल्स?
Because if you go for the population, it is too much. Suppose the 3,000 patients का आप सर्वे करना चाहते हैं,
हाँ,
headache. So you take a sample, and but
Yes.
to find out the population, what happens to the TB patients? That's why we are doing this, right?
But for that, we should know what is the correct population, na, sir? वो एक
but,
main रहता
but then based on that we are taking sample, no?
है. Okay.
So without sampling, how do we take a sample? So when
Okay,
we
sir.
take a
Yeah.
sample, we know the population. Even if you don't know the population, for example, it's a huge city like Bombay, you don't know how much is the exact population. But then when you take a systematic random sample, for example, every 10,000, every 20 house, when you take, or you have electoral list from systematic random sample technique. So you need to have a sampling frame. Without that, you can't take a sample. So Dr. Alvin, you have any problem? You know 5 types of Z?
Yes.
Dr. Alvin? Or Dishant, are you listening?
Yes, sir. Can you later on share all the formulas for the 5 types of Z? If
Of
possible?
course, the formula will be given, there is no problem. And also, you will have a table where to apply what, right? But then let's go for info and see how it can be done. And
But sir, इतना बड़ा population का mean निकालना भी तो इतना difficult है ना sir?
हाँ, इसीलिए सैंपल लेते हैं ना. That's why we take.
हाँ, पर अपने को population का mean भी तो मालूम होना चाहिए ना. Sample का तो mean आता है सर, पर population का mean कैसे निकालने का?
इसीलिए तो हमने बोला कि population mean sample mean plus minus 2 standard error.
Okay.
That will give you population mean.
Okay.
इसलिए तो हमने ये formula निकाला.
Population. Okay.
Standard
We
mean,
found. Yeah.
population belongs to sample mean plus minus 2 standard error. Now let's try to use it AP info. Automatic ये कैसे निकालते हैं वो हम आपको बताएंगे. So for that, I will share my screen. You can see the AP info.
Yes.
So I hope that all of you have installed AP info. If you have not installed, you should do it, right? What we are doing, for example, in a village of 10,000, you want to find out how many patients are suffering from tuberculosis. You are doing a study, that is a cross-sectional study. Today you want to find out, right? What you get is a point prevalence. If you do a study over a period of 1 year and find out how many new cases plus old cases, is a period prevalence. If you want to find out for each case of tuberculosis, there is no case, only a normal person you want to compare and find out these people are having why tuberculosis. That is a case control study. But then why the TB develops, how it develops, if you want to find out that, then in that case, suppose your theory says that the people who are having a less immunity will have more tuberculosis. Then you need to have two kinds of population, less immunity and more immunity. You need to measure the immunity. Or in some cases, you want to find out the difference between male and female. Then you follow them up for a occurrence of tuberculosis. Then if you have taken 2 cohorts, then it is known as a cohort study. You start with the exposure, non-exposure. Then you try to find out outcome. Then you may try with the vegetarian diet, non-vegetarian diet, find out whether the autoimmune disease occurs in which population. Then also it is a cohort study. So cross-section study, case control study, and cohort study. In this case, we are going to refer that day I show you the Oswego file. So people suffering from the disease, right? Illness, because they've taken some food somewhere in a party, 75%. Now here, most important thing that you should find out which types of file you are using. If you are using Excel file, you should select XLS like this. If it doesn't read that, then you convert a file in the older version. So, because most of you people will be using Excel file for data. And if you are using AP info directly, then the project file. Now we are doing right now project file because you are learning. You browse, that means where is your file located? It is, they give in a projects. And in that there are so many projects. You can try it out, commercial project, cholera, whatever it may be. But this is a simple, is most easy. So you select the project file like this and use the open command. Once you say you have selected the sample, in that also project there are so many files. We select Oswego, that is easy to understand. Yes. And all of you by the next Monday, at least you should have 10 or 15 data filled up. Maybe in a Google Sheet or in Excel, hypothetical or actual. Actual will be much better. And you will have such kind of file. And then on that day, we try to learn these three commands: frequency, tables, and means. And also we use the logistic regression. So we'll repeat those commands so that you can understand. Now in this case, first we use the frequency. Today I will not going to use all the frequencies. I'll be taking only, let's say, coffee. Now, here, can you see the standard error of proportion somewhere over here? Anybody? Is there any standard of proportion here?
Error of proportion.
Not seen directly, but indirectly they have.
Confidence.
So how you can say that? 41%, right? Took a coffee, 41%. But suppose this 75 is out of 1,000 people. And the question is asked to you that how many person out of 1,000 people would have consumed coffee? Suppose this 75 is not a total population, is a sample of 1,000 population. I repeat, right now, how many people we have? 75, right? If this 75 are taken out of 1,000, what will be the percentage of who are consuming coffee? In this sample is 41%. But in 1,000 population, the percentage will be 30 to 53% will take coffee. So if you want to prepare a coffee for 1,000 people, maximum people will you get is 530. You prepare that much coffee. Understood? This range which is given by the AP Info over here, they calculate the what will be the population proportion. Understood this? I repeat.
Yes, sir.
Let's say that I want to find out. I give you a question. Milk. Say you have a 1,000 population from which the 75 people were taken, and you want to give a 100 ml milk to one individual. So 1,000 population, how many liter of milk is required based on this data?
50, 53.
So maximum number of people who will consume the milk will be 13%. 13% will take consume milk. 13% of 1,000, that is 130. 130 into 100 means
13,000.
13 liter. 13 liter milk will be sufficient for 1,000 population if this is a representative sample. Agreed?
Yes, sir.
This is how we apply standard of proportion for the population. Now, another question. Suppose 1,000 population may say 75 are taken as a sample. And I find out the frequency of, this is the last of its example, then we'll change other thing. 61% become sick. And we have hostel students, 1000 students, usme se we took a sample of 75, 61% found to be sick. So what will be the total sickness load, or how many students are likely to be sick in a population of 1000? Tell me that.
610. 610.
No.
Around 700.
720 around.
720, between 490
Yeah,
to 720.
20, huh? Yes.
490 over here to 720, 49 to 72%. Maximum would be 720, minimum would be 490 out of 1000 students. So accordingly, you prepare yourself. So I think this is a very clear. And now we go for the tables command, the relation between two variables.
So can you go back, sir?
Yeah.
Sir, here the exact 95% and conflict limit, it says the standard error, standard deviation.
So I take a 0. This is a standard, the percentage plus minus 2 standard error of proportion. See, no is 69%, right?
Yes, sir.
So, this 57 plus 79, how it is arrived? This is a P plus minus 2 standard error of proportion. This is how they find out 57 and 79. This 69. So here the standard error would be around 5. So 69 plus minus 10. That will give you the 57 to 79. How they calculate like that. But they don't want to show you the standard proportion. They give you directly what you want.
Okay, sir.
Population में इतना होगा based on a sample, right? But when you compare two population, for example, tables command, the difference between here you can say that the consumption of chocolate versus sickness. This is a standard error of difference between two proportions they compare, and then they will give you the p-value. And here, because they have advanced statistics, they directly go for chi-square test and give you the result. And then they give you the p-value. So you can see the data. How many took a chocolate ice cream? 47. Usme se 25% becomes sick. 25%, there's 53%. While a chocolate was not taken, then 74% becomes sick. So here says this, they say that chocolate is little bit protective. It looks like this. And we see the difference, 53% and 74% difference. Is this significant or not? Look at the p-value over here, 0.07. Although it looks protective, it is not exactly statistically significant because p is more than 0.05.
0.05.
So we say that it is not significant. But the same result, if you compare, when you take a vanilla and then compare with the sickness, it's become so easy to find out. Vanilla took 79% sick, not taken only 14% sick. You can also see the symbol of each, no? And
Yes, sir.
then you look at the p-value is less than 0.00005, much less. So there is a strong
is.
correlation between the vanilla and the illness. They are associated. Vanilla is likely cause of the sickness. So are you well versed with the command of tables command?
Yes, sir.
Yes.
So you try to use in your case also. Now we go for the means command. In means command, we want to find out is there a mean age of difference between those who taken means of age versus the chocolate. People are taking chocolate, not So small children are taking more, or is there something like that? So what we say that no, 43 was a mean age amongst those who are not consume chocolate. While the mean of chocolate user 32, you can say that young people, they like chocolate, they prefer the chocolate. And this 32 mean and the standard deviation is 20, 22. Is it significant or not? For that, we use F-test and the p-value is 0.03. You can say that there's a significant difference between the age group, those taking chocolate and not taking chocolate. Younger people choose chocolate more than the older. That you can see over here, right? This is p-value is less than 0.05. All are agreed? This F test you need not understand detail right now between the group and within the group, but you look at the p-value, right?
Yes,
Is
sir.
0.03. There's most likely that those who are taking chocolates are relatively younger, and the older people usually they'll prefer chocolate less. Similarly, you can have the means command, then you have this logistic regression. This you are using to compare multiple variables at a stretch, right? So this is, we want to see the outcome of illness. And illness is because of which variables? You take 2 by 2 tables. So yes and no like this, no? Chocolate, then you take the male-female ratio in causation of illness, vanilla, then you can take mashed potato, then you may take spinach. So you have taken, let's say, around 6, or you may go on board for the 7th variable. Let's say the coffee. So out of this, which variable, which is more positive in causing of the illness, that you will be able to find out. You select like this and say, okay. Now here you get, closely look at the data. This into bracket is more important. Yes, no. Which kind of comparison this is? That it compares yes and no. That here is 1.9. If cakes are taken, 1.9 more. If chocolate is 0.7, that means reverse ratio. In male female, reverse 0.24. That means the males are having less problem. Vanilla, yes, 29 times. Spinach 0.7 reverse. Mashed potato 1, that means almost similar. And here, if you look at the p-value, is 0.04. It is significant. And if you look at the vanilla, Z is 4. That means P is less than 0.00001. So highly significant, right? So we can say that the males are less affected and people who are taking vanilla are significantly higher affected. This is how we find out which factor is more important. Any question on this? So for you, the p-value is most important, right? So here, there are certain other commands which will not cover, but if you want to learn any of this command, right? For example, recode, assign, there are so many commands. Then you go for the online help, or you can go for the tutorials of the Happy Info which are available online. But for you, as of now, these are the important commands. For advanced users, you may use something like select command. You take only the few people who are having age more than this, etc. You can use, and then you can work on that. The only thing that which you should remember right now, where it is automatically, because you want to ultimately publish your paper, you want to know this, where these are the saved. So you can see over here, output 41. And if you want to route at a particular, the route out, you can select which folder you want to select. That is also possible. Otherwise, by default, it goes to output 41. We may try to see where this is 41. Right? So, where is this 41? If you want to find out, yeah, you can go.
Sir, can we directly copy and paste wherever in a Word
This is
document or
not the right
something?
thing to do. Output 40, for example, output 41. Output 41. Just show you. I will share the screen and then it will be easier for you to find out. Can you see the screen?
Yes.
Yes, sir.
Here, I'm just showing where my file is located. In output, and there is a 41. This is 41. So this is where it is, right? जो हमने कुछ काम किया, everything is said over here. So you should know जहाँ से आपका AP info चलता है, in that folder it will be there, right? So this is when you install your AP info, you should know where you have installed. So you need not copy and paste because it is already given to you. Already all the automatic saving process there. So I hope next time you will be using AP info successfully, and then we should be learning about the study design epidemiologically, and then try to correlate with this AP info analysis. And we should be able to after 2 or 3 sessions, we'll be going for non-parametric test also. Where do you go for the various, if your sample size is very less, what will you do? Only 10 or 15 are there. You don't have hundreds of that. That will be looking after a few sessions. And you'll be given access to our educational platform. You should register in that. So to all these videos also, or previous videos, you can see from that education platform. That will be sharing on the Monday morning mostly, so that you can start utilizing, look at the videos, etc. So any question?
Sir, in AP info, can we make pie charts, bar charts, and
Yeah, all the charts is possible, but that you can do in Excel also. So if
Okay.
you import the charts is possible.
Sir, I have a general query. Like, what's the exact difference between AP info and SPSS? Like SPSS.
SPSS is much better, much better. But the thing is, the amount you can use illegally. Otherwise, the amount is 1.5 lakh, 2 lakh, 1 lakh like that. So, and most of the time we don't need the SPSS unless there's an advanced statistics to be used. So, this is a free version. So why not to use free version, right? That's the only thing. Otherwise, AP info will give you a lot of the detailed analysis as compared to the AP info. And the SPS is much faster if you know how to use it. It gives you, here we need to tables command and this. It will give you 10 variables, 100 tables in no time, right? So that way is more speedier and more advanced statistics, you can do that. But for our beginners and basics purpose, this AP info is sufficient. And the SPSS usually does allow you the data collection tool, data entry tool, etc. is not there. You need to have a ready-made file for that. Anything else? Okay, we'll see you next time. Thank you.
Thank you, sir.
Thank you.